Okay, starting chapter 3. I'm recording. Chapter 3 is stoichiometry. Y'all ever heard of stoichiometry before? Okay, remind me, who did not have chemistry in high school? Okay, Wesley. Huh? You did this in high school?
Oh, yeah.
You did?
I did, but it's hard.
It's hard? Oh, this will be fun.
I didn't like it.
This is math, okay? This is math. There's a lot of math. I'm going to change your mind, Tanner. You're going to like it now. Okay? Keep an open mind. So, stoichiometry deals with like ratios and things. For example, this is what stoichiometry is really about. Y'all know what this says? It doesn't say what you think it says.
Converts to?
It says that 2 pieces of bread, 2B, and 1 piece of cheese, 1C. What will that make? 2 pieces of bread and 1 piece of cheese? A sandwich. Okay? That's stoichiometry. So y'all, what if I have 4 pieces of bread and I have a whole bunch of cheese? How many sandwiches can I make with 4 pieces of bread and a lot of cheese? How many sandwiches can I make?
2.
2. That's easy, yeah? That's tangible. That makes sense to us. What if I had a whole bunch of bread, but I only have 4 pieces of cheese?
4.
4 sandwiches. Okay. Makes sense, yeah? How come 4 breads only makes 2 sandwiches, but 4 cheeses makes 4 sandwiches? How come, if I'm starting with the same number of both, how come I can't make the same number of sandwiches with both? Because it takes 2 breads on every sandwich, right? Y'all, that is stoichiometry. That is, in chemical reactions, that's what we're doing. We don't always mix things like 1 egg and 1 flour and 1 vanilla makes 1 cookie, right? That's what stoichiometry is. It's just not always with breads and cheese and sandwiches and stuff that makes a lot of sense to us. Okay, that's where we're going. So, we're going to start by learning how to calculate something called a molecular mass, also called a molecular weight, also called a formula mass, also called a formula weight. Okay? The units for these calculations for the mass of a molecule, because that's what molecular mass is. It is the mass of a molecule. The units for the mass of a molecule are AMU. What does AMU stand for? Atomic mass unit. Atomic mass unit. So how do you calculate the molecular mass of something? Well, you need to know the formula. Y'all, what is the formula for calcium sulfate?
Calcium sulfates.
Say again? I think you're saying CaSO3. How about CaSO4? Yeah? Calcium sulfate. So look, on test 2, I'm going to write calcium sulfate. It'll be something different, right? I mean, it'll be barium nitrate. I don't know. But I'm telling you, on test 2, I'm not going to write chemical formulas because we already know how to do that, don't we? Isn't that what we just tested on? So on test 2, I might say, calculate the molecular mass of calcium sulfate. And in order to work that problem, y'all are going to have to know, okay, calcium sulfate is CaSO4. Now, in CaSO4, do y'all agree that it contains calcium and sulfur and oxygen? How many calciums are in CaSO4? 1. This part's easy, yeah? How many sulfurs are in CaSO4? 1. How many oxygens are in CaSO4? 4. Do you know what the mass of a single calcium is? I see y'all looking. You're going to the periodic table, right? So go to calcium. And look, here's my rule on the periodic table. I always take 2 decimal places, okay? So y'all, some of these numbers, like, my goodness, look at gold. 196.96655. If you just take 2 decimal places, that is plenty, okay? No matter what you're doing. So for calcium, do you see I've got 1 calcium, and 1 calcium has a molecular mass of 40.08 AMUs. What's sulfur? What's its molecular mass?
32.06. You know what this is?
Yeah, it's 0.066, so we're going to do 32.07 AMUs. If y'all still have those periodic tables that I handed out to you, because I mean, you can look up here, but it might be hard to see. What's oxygen? What's its? Yeah, it's 15.9994. So if I want 2 decimal places, do y'all see you're going to do 16.00 AMU? Then what do? We get our handy dandy calculator and we multiply them together and add them all up. So tell me what you get for the molecular mass of calcium sulfate. You know what? I think y'all better add them up again. Tyler, what'd you get?
136.6.
Okay.
I did not get that number.
Add them again. If you didn't get that number, you're putting something in wrong. Because that adds up to 136.15. That is why I like these graphing calculators, because I can see what I entered. What'd you do wrong, Cameron?
I had SO6, I don't know why I had 6.
Oh, okay. Okay. We good on that, 136.15? Okay. Let's do another one, a little bit harder. What if I said, I'm going to change slides on y'all. What if I said calculate the molecular mass of magnesium?
So is that whole problem?
That's that whole problem. That's not bad. But in all fairness, Austin, we're like 6 minutes into chapter 3. So, do I need to go back a slide, y'all? Did I jump? Okay. You can say that. You can say, hey, go back. Okay. Can I move now? Magnesium nitrate. You gotta know the formula. What is it? Work together. Tell me it.
So Mg.
Close. MgNO3. I heard that. Swap and drop. MgNO3 2. Okay. How many magnesiums are there? There's 1 magnesium.
So you don't bring.
No, this 2 only is for what's in the parentheses. How many nitrogens are there? 2. How many oxygens are there? 6. We all agreed on those numbers. Then I go to the periodic table and I look everything up. What's magnesium's mass? Yep, 24.31 AMU. What's nitrogen? 14.01. Yeah, I think I heard Sawyer or somebody say it. And then oxygen is 16.00. I got 148.33 AMU.
$148.33.
Mm-hmm. Easy, right? The most challenging part of this is knowing the formula, because if you get the wrong formula, you're going to get the wrong answer. Now, let me tell you where I want y'all to get, okay? You see this? I'm putting in my little red box. I would like for you guys to get so good at calculating these formula masses that you don't have to write all this. That you're kind of, with your calculator, you're saying, okay, there's one magnesium, that you're just doing it in your head, okay? Do you have to get there? No, but I'm telling you at what level, because we're going to do some much harder stuff with this, okay? And how are you going to get there? You got to practice. I mean, how do you eat an elephant, right?
One bite at a time.
One bite at a time. Okay? So, now let's do something more with this. Let's calculate something called percent composition. And now, what if I asked y'all in this room right now, what percent of the people in this room are wearing a cap? Y'all start looking around, because what are you doing? All right, how many people are wearing a cap? 3, right? There's 3 people wearing a cap. Is it 3%?
No.
No. How do you figure out the percent?
You have to figure out how many people.
Right. The percent's always a part divided by the whole, right? How many total of us is it? Is it 13? I'm going to go with that. I hadn't counted it yet. I count. I'm people. So what percent of the people are wearing a hat? You all know you'd say 3 people are wearing a hat. There's 14 people in the room. 3 divided by 14 times 100%. What's it?
21.4%.
21.4%. How do 0.4%? Well, that's just percent, right? Okay. Y'all know percent is the part divided by the whole.
Mm-hmm.
Nothing new there. So, what we want to do is calculate the percent composition of each element in magnesium nitrate. Calculate the percent composition, and I should clarify, it's by mass, okay? Percent by mass composition, or percent composition by mass of each element in magnesium nitrate. Now, we're going to use our work that we just wrote, right? Our magnesium nitrate. So guys, what percent of magnesium nitrate is magnesium? And y'all are looking up in your notes. It's on a previous slide, so I don't have it right here in front of me. But for percent magnesium, do you see that I've got one magnesium, right? And a magnesium is 24.31 AMU. That's my part. What's the whole? The whole is 148.33 AMU. And then I multiply it by 100%. I got 16.39% magnesium. Yes? Y'all always check my calculations, because sometimes I do it wrong. If your number doesn't match, don't be afraid to say, hey, I didn't get that.
16.39.
Yes. Okay? Now, can you guys do the percent nitrogen and the percent oxygen on your own? using that as a template, I think you can do what percent is nitrogen, because it does say of each element.
Wait, how did you do that?
I said 1 times 24.31 divided by 148.33 and then times 100. You already got them all.
That's fine.
Tell me when you get nitrogen. What you got?
18.89.
That's what I got. 18.89% for the nitrogen. Okay. And y'all are working on the oxygen. Okay, 64.72. Okay, that's what I got, 64.72. It's nice. On your next test, question 1 will look like this. It will say, calculate the percent by mass of each element in, and then I'm going to name a compound. It's probably not going to be magnesium nitrate, because I want you to come up with a compound and do that. So that is, Austin, that's easy? Yeah?
Oh, so.
Okay. That should be easy. So that's number 1 on the next test. Now, there's one more thing I want to get to. I've got 4 minutes left, but I want to cover this. Balancing chemical equations. And honestly, I wish I didn't have to cover this. I wish you guys all knew it, but I don't know. I don't know where, just because you had chemistry doesn't mean you know how to do this. So look, I'm going to say that, let's make it more difficult. What if I told y'all that hydrogen and oxygen react to make water? If I wrote that sentence, hydrogen and oxygen react to make water, could y'all take those words and write chemical formulas and symbols with it? Okay, so some people are probably thinking, I'm not really sure what she means. But when I say hydrogen, what's the symbol and formula for hydrogen? Be careful. You know it's H, right? What's the formula? For hydrogen, just hydrogen. It's got to be H2, doesn't it? How do you know it's H2? Remember the diatomic? Remember you got to always include hydrogen? And then do y'all remember talking about that? The 7 on the periodic table? No? I don't know if I wrote it. Hang on, this is just to see if I talked about it.
You did.
I did? I didn't find it.
You're supposed to mark it on.
Ah, shucks, I can't find it. It doesn't matter. Okay, I'll rehash it right here. Hydrogen and oxygen. And on oxygen, you're going to write O2. Okay? And so what I'm asking y'all to remember that we're going to hit it real quick because not everybody remembers it. There's 7 elements that are diatomic. And one of them's hydrogen. Okay, it's off by itself. Okay, now we're remembering. I hear it. The other one, remember it's the NOFClBri. Remember they make a 7? So when I say, like, if I said hydrogen and bromine react, you would say, oh, bromine's going to be a Br2 because it's in that group. Okay, so hydrogen and oxygen react to make, does everybody know you do a little yield sign, a little arrow? And then you'd put water, H2O. Okay. By each one of these, I have to put something in parentheses. I got to put solid or liquid or gas or aqueous. Hydrogen, is it a solid? It's a gas. How do you know it's a gas? I think there's 2 answers to that.
What group's in it?
Huh? Say again what y'all are. Okay, it's red on the periodic table in the room, right? Reds are gases. But I also think that one might be some common knowledge. We know hydrogen gas is a gas. What about oxygen? That one for sure is common knowledge, yeah? It's a gas. And now water, you could, either way is accepted because in this room, water would be a liquid, right? So we can put L. It's not wrong if you put G. Okay. That's not balanced. Because on this side, y'all, those are called reactants. The H2 and the O2 are reactants. Everything to the right of the arrow, those are called products, yes. I know I'm going into overtime a little because I wanted to get through this, so just bear with me. Do you guys see that on the left side of the equation, there's 2 hydrogens and 2 oxygens, but on the right side of the equation, there's 2 hydrogens and 1 oxygen in water. Okay? The law of conservation of mass says you can't do that. It says you can't mix 2 hydrogens and 2 oxygens and end up with 2 hydrogens and 1 oxygen. Because the law of conservation of mass says that elements don't disappear. So how do I fix that? Here's how you do not fix it. Look, watch water. Can I fix it by just doing that? No, because that's not water. H2O2 is hydrogen peroxide. You can't fix it by changing the subscripts. You fix it by changing the numbers in front, right? The coefficients. Just like the bread and the cheese in the sandwich, right? 2 breads and 1 cheese makes a sandwich. So, I think y'all know how to fix this, but I don't want anybody to think, oh no, I don't know. So y'all are going to have to kind of be honest and put yourself out there. Does everybody in here know I'm going to put a 2 on water? Okay, that's going to make the hydrogen be 4 and the oxygen be 2. So I fixed the oxygens, but I messed up my hydrogen. So that means I'm going to go to the reactant side and put a 2 on hydrogen so that I can make there be 4 hydrogens. Yes?
You kind of lost me a little bit.
Okay. I'm going to stop because I'm in overtime. We'll we'll hit this again on Monday. Yeah. We'll do some more of those on Monday.